Welcome to The Explainer. Okay, think about your favorite podcast for a second. What makes it so good? I mean, beyond the topic, it's the voice, right? The emotion, the flow, that human touch. But what if an AI could do all of that perfectly for a full 90 minutes? Well, today, we're looking at a new technology that's trying to do exactly that.
So the whole thing really boils down to this one huge question. Could an AI actually host an entire podcast? I'm not talking about a little soundbite. I mean a full-length, multi-person conversation, from the intro music to the sign-off.
Well, it turns out the answer is a resounding yes. And get this, when real people listen to a bunch of different AI voices, this new model, VibeVoice, didn't just hold its own, it blew the competition out of the water. We're talking about outperforming heavy hitters like Google's Gemini and 11 Labs on the things that actually count: realism, richness, and just which one people preferred listening to.
And, to really get how big of a deal this is, you have to think about the old way of doing things. Most AI speech is basically just tiny audio clips glued together. The result is, well, you've heard it. It's that robotic, clunky sound where the AI has zero memory of what was just said. There's no flow, no real conversation. And that's exactly where VibeVoice changes the game. It's a system designed to create a whole 90 minutes of audio with up to 4 different speakers, all in one single continuous go.
So how on earth does it do that? Okay, to really understand what makes it tick, we've got to pop the hood and see how the engine works. Okay, so here is the absolute key difference. The old way is like making a patchwork quilt, stitching tiny, separate pieces together. VibeVoice, on the other hand, is like weaving a single giant tapestry. It thinks about the entire 90-minute conversation as one whole piece, so it understands the context from start to finish.
And the process itself is actually pretty straightforward. First, you give it 2 things: a voice sample to know how someone sounds, and a script for what they're going to say. Then, the system's brain, a large language model, reads the whole script to get the context. After that, it kind of sculpts the audio, and out comes the final speech.
But here's the real magic, the secret sauce, if you will. It's a piece of tech called an acoustic tokenizer. Now, the easiest way to think about this is like a super-powered audio compressor. It takes these gigantic audio files and shrinks them way, way down, but, and this is crucial, without losing all the little details that make a voice sound real.
And when I say super-powered, I mean it. Check this out. It compresses the audio data 3,200 times. That is just a staggering number. And that efficiency, that's the whole reason this is even possible. It's what allows a computer to actually handle a 90-minute chunk of audio without completely melting down.
All right, so the tech sounds amazing on paper, but how does it actually stack up in the real world? Let's take a look at what happened when they put VibeVoice in the ring with some of the biggest names out there.
So to test this, they set up a pretty intense bake-off. They took about an hour's worth of complicated conversational scripts and fed them to the different AIs. Then, they had 24 actual people sit down and listen to all the results. We're talking 6 hours of listening per person to rate everything. And when the scores came in, well, it wasn't even close. The human listeners were clear. When it came to things like, does this sound like a real person? Or how expressive is the voice? And, most importantly, which one would you actually want to listen to? VibeVoice was the clear winner. Every time.
And it wasn't just about opinions either. They ran objective tests too. They measured something called word error rate, which is basically just a count of how many mistakes the AI makes compared to the script. And guess what? VibeVoice had one of the lowest error rates, meaning it was incredibly accurate.
Okay, so we've established it works, and it works really well. So let's step back for a second and think about the bigger picture. What does a technology like this actually mean for the future?
Well, for anyone who makes content, this is a potential game changer. I mean, just imagine, you could turn an entire book into an audiobook with a full cast of characters just from the text. Or you could generate a whole podcast series from a script. It really could open the door for so many people to create amazing audio.
And this quote from the original paper really nails why this is so powerful. It says the model achieves perceptual excellence, despite aggressive compression. In plain English, that means it sounds fantastic even though the data is squished down like crazy. And that combination, high quality and high efficiency, is what makes all this new stuff possible. But like with any powerful new tech, there's always a but, right?
we have to talk about the fine print, the limitations, and of course, the potential risks. For starters, right now it only works in English and Chinese. It also can't do things like add background music or sound effects, and it's not great at handling people talking over each other, like what happens in pretty much every real conversation.
On a more serious note, the creators themselves are very upfront about the risks. A tool this good at creating realistic voices could obviously be used to make very convincing deepfakes for scams or spreading disinformation. That's why they're making it clear. This is a research tool, and it needs to be handled responsibly.
And all of this kind of leaves us with one big final question to chew on. When AI voices get so good that you literally can't tell them apart from a real human, what does the word authentic even mean anymore?